Okay. How do I take the
rational functions. We started this a little bit yesterday. It's basically you expect to see a ratio of two polynomials. X's with powers on the top, X's with several powers and numbers together. That's what rational expressions are. I warned you about some values, restricted values they are called. You need to avoid them in your domain because they make the function undefined, such as 0 for this one, -4, 3/2 for this one, and nothing is restricted for the bottom one. It always works fine with any function numbers. And we were investigating what happens around those restricted values, what's really going on. So we need to avoid those values. This is a good example of why function avoids that value, because when you get closer to that restricted value, here is x equals 0 is restricted for 1 over x, right? 1 over x, when you substitute 0, you cannot read the data. So you kind of have a danger zone, red danger zone over there. So your function avoids that red danger zone by any means, by going all the way either down or all the way up on the sides of that danger zone. We call this situation asymptotes, vertical asymptote. And you expect your function to go either infinity or negative infinity, or sometimes both ends going up, both ends going down. Okay? And this 1 over x, somebody built values for left side of 0. You see, you are taking negative, very close numbers to 0. And right side of 0, positive, very close numbers to 0. And your function values are rising and rising for the right side, and sinking and going further down, bigger numbers, negative bigger numbers, when you're on the left side. So we call when you function, when x values are approaching 0, this little minus sign means left. When you're approaching to 0 from the left side, function goes to negative infinity. Literally it's going to negative infinity. And we are approaching to right side of 0. This means right. And the function values, look where they're going. They're rising, rising, and rising on the right side of 0 to infinity. What is the other two table for that? There are two more tables investigating a property of 1 over x. The left side, look at the x values. Where are they? X is -1, is right here. And then I'm lost. I can't find -10. Where is -10? If this is -5, -10 is somewhere here. -100 is all the way on the left side, far, far left. And even 1000 is really, really on the far end, right? But these are still not too big. Imagine 1 million, 1 billion. You can go lower and lower in this sense. But what's happening to function values?
Smaller.
It's getting smaller and smaller. It's almost 0. So can you expect eventually, when you're on the million side, when you're nearing the million, negative million, far, far end, you expect this value to drop to 0. So kinda, my function is approaching something horizontal here. Look, there is a horizontal electric fence now, just like vertical fence. Now somebody built a horizontal electric fence. Your function never crossing it, but getting almost close to it. It's like attracted. You're attracted to it, but you're not touching it. This time, whatever was happening vertically, happening now horizontally. Guess what we are going to call this light to be? We're going to call it horizontal asymptote. Asymptote is kind of magnet, attracts my curves, but dangerous magnet. It has electric on it. You don't touch it. You get close, but never touch it on the ends. Can you touch it in the middle? Yeah. This part, middle part, is safe. You can touch the green line in the middle part. I'm talking about the ends, far right and far left end. Again, we are checking only here. X going to negative infinity means far left. Right? Isn't negative infinity on the far left end? So you're checking the approaching on the left. And we see y is approaching to 0 level. 0, number 0. Right? This means x is like millions and billions, but positive means far right. How far? Think of the furthest point here. And where are we approaching on this part? Your function gets really close to that green line level, which is 0. So we call it y going to 0. Okay? So these observations now will be put in word in the next stage. We will call them, again, I already mentioned them, vertical asymptote, and we will call them a few minutes later horizontal asymptote. We won't be finding them on pictures anymore. There is an algebra. We can directly find them from their equations. But before that, let's see how well you understood these concepts. Let's check. Let's do an activity. Question number 1. Look, everything I said in words here, now we need to transfer it into expressions, mathematical notations. So, but when you're reading them, just understand, turn them into sentence. What does this mean? X arrow negative infinity. This means x values. When you are taking x values, what kind of x values? What kind? Positive 10, 100, 1000? No, negative infinity means negative huge. This means far left. So it's saying on far left of the picture, where is f of x values approaching to? What value they are getting nearby? What y values are you getting nearby? So far left, where is far left? This is x and y, this is x-axis. Far left of x-axis is this side. Put yourself on the picture. This is you. And look where your level is. What level are you on? I mean, your foot is around this level. Right? You just need to read me that level. What level are you approaching when you go far left this side? You were walking and walking, you're kind of rising, but what level are you getting closer to? What number is that? 2. You need to read this on y-axis. This is y values. Y values of these dots are almost, let me clean this, it's too messy now. Let's talk dots now. Here is one dot, here is second dot, here is third. Their values are almost, look, they are kind of climbing slowly. They are getting to this value, which is 2. Okay? Every moment you go left, you're rising 1 up. Go left, a little bit up, incremental up. But eventually, you will almost be touching 2. So we go ahead and put 2 here. Okay? So part A is 2. All you need to do is answer each of these parts. You don't need pen or pencil here. Just observe and find out. What does this mean? Can somebody translate this into English? X arrow 3 and a minus on the corner. What does that mean?
As X approaches 3 but doesn't touch it.
Yeah, it approaches 3, but you can approach it on both sides. Which side of 3 are you on?
Well,
Minus means left. So you are sitting somewhere close to 3, so you need to find 3 on x-axis. So let's find it out. Where is 3? Here is 3 on x-axis. Where is x-axis? This is x-axis. So this is the moment 3, exact 3. But that arrow means you're not exactly 3, you're approaching to it. I'm approaching it from left side. Okay? I put 2 marks, you can approach more, 3. And track these arrows on function. When these arrows marching towards red dot, where is the arrows marching towards? Which direction? Which y value? Oh, it's this one is at -1, this one is at -1.5, this one is at -2. So is it -2 the maximum? Now just think continuously you're going further down and down because they will approach closer and closer. Eventually they will go unlimited, huge values. So what is the final result? What do you say? Minus infinity. Okay? How about the right side? Just think the other side of 3 now. You're on the other side of 3. Your arrows are approaching from this side. Getting closer and closer. Now where is my curve? Here. So choose a different color. Black. This arrow is going to create this one, that, that, and that, right? You put one more, you are moving up. Get closer, you're moving further up. So where are the values going? Anyone? Infinity. Yep. Did you get it now? Any questions? What does this mean? This symbol. This is which side of the x-axis are we taking a look at now? X is going to infinity means left side? Right side. This is the far right side. It's asking on the far right side. Here is far right I can go. Where is these values leveling to, approaching to? Where is it? It's this dashed line again. It's same tube as earlier. Okay? Alright. Now some basic other observations. What do you think? Is the graph increasing over at least one interval? What does increasing mean? When you are traveling on this path, on this graph, put yourself on it and travel from left to right all the time. Do you ever feel going up? Yeah, this part is going up, right? So it's increasing. Correct? Look, it's going up. Arrows are going up, so we are increasing. This graph has an increasing part. I will go ahead and say yes. Is this function decreasing sometimes? Yeah, it's going down sometimes. Look, this part is going down to negative infinity. Yes. When I check, it's going to say incorrect. Where is my mistake?
It's not increasing.
It's not increasing? How come? It's going to infinity. How can you say something going to infinity is not increasing? Because the test is this. You are moving from west to east always, and you need to be checking if you're rising or sliding. Look, are you rising here when you move from left to right? No. I'm sliding, slowly sliding, and then fast slide. Here, I pop up again here. Look, immediately I disappear on this side and pop up this way. And what's going on here? Are you climbing when you go to the right? It's slide, further slide. I was sliding, 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 immediately popped up here and then sliding again. Never, ever increased. This is not an increase. When you were here and there, this is not an increase. You disappeared and popped up back. So this is always decreasing. Okay? It's never increasing. Okay, now you need to write the intervals. It's increasing, no, decreasing, because it's never increasing, right? It's never increasing, so we just need to find where it's decreasing. What intervals is it decreasing? You need to now tell me where this graph goes down on x-axis. What about what x-axis part, this picture goes down. So on this region, is your picture going down here? About this region? Under this region? Yeah. So I should take this, right? And then let's take a stop. So it's still decreasing. And then it's still decreasing. So I will take this part as well. I'm coloring the wrong part. This is not x-axis. It's not x-axis, right? So here is x-axis. So above this region, are your picture going down? Yeah. So this is decreasing interval. And then I continue and it's still decreasing. So I will say the whole x-axis, entire x-axis from negative infinity to infinity. Am I right? Negative infinity, comma, infinity. I'm wrong again. I don't know this subject very well. What is wrong?
Can't have 3 included.
What's that?
You can't have 3 included.
We cannot have the bad guy that gave us a headache earlier. Who was the bad guy? X equal 3. This is electric fence zone, right? This part is a restricted value. Restricted value. That means that number makes your function sick. How do I know it makes sick? Because there is no value above it. Your function gets closer to it, or it never touches it. Must be taken apart from your domain. If it's not in your domain, your function can't be decreasing there. So you need to take it away. So it's 3, right? Unite everything before 3 and after 3. Okay? I just removed the number 3 by creating 2 pieces, left piece and right piece. Does it make sense? So it's not actually decreasing over the entire interval of x-axis. There is a break at 3. Okay, what is the domain of this function? Are there any values you have no response from your function? Are there any interruptions? Function has no value over there? Are there? Where? At 2? Look, 2 is here, and I can read its data. At 2, function becomes 1. It's not 2. Look, there is no interruption at 2. At 2, I have this value. The point is 2, comma 1. Nope, function is well defined at 2. If you don't have any bad value, I will just say minus infinity to infinity.
It's 3 again.
It's 3 again. Do you have anything above this number? When I enter 3 into x, do I get a y value? No. Your function is never ever touching to this line, vertical line. It's never crossing. If this was crossing, yeah, I could say, oh yeah, here we go. At 3 I have this value, but it's not. It's not crossing. So we again have the same answer actually here. We just need to copy this there. All right, 3 more pieces. The range. What is the range of this function? Range is obtained, by the way, domain, another way to see domain is you compress this to x-axis and you get the domain. Now range is, when you compress this to y-axis, the image you get is called range. So smash this to y-axis, this blue picture to y-axis, towards y. Tell me, read me, what interval do you observe there? Negative infinity, infinity everywhere, right? Look, I smash this part to y-axis, I get this. Keep pushing, and I get that. Keep pushing this side, and then there are points coming in from this. These points are coming in. So I color everything so it's infinity and negative infinity, everything in between, right?
You have to exclude 2.
Yeah. Take a deep look at here. Are there any values right at this level coming from this side? Any values coming on this blue curve and hitting here? Any values coming from this side hitting here from this blue curve? No. So we exclude this value, which is 2. So you have a hole at 2. So how do you write this? How do you cover everything from deep down to 2, except 2, and continue after 2? Come on, speak up.
Negative infinity to
Yes. Negative infinity to 2, comma, union 2 to infinity. Okay? Alright. We didn't technically define what vertical asymptote is, but I described what vertical asymptote on picture before. So you're ready to name it. What is the electric fence? Right up and down, running up and down, vertical on this picture. Where is it? 3. So you just need to set it into x. Vertical asymptotes have always this fixed equation. It's x equals something all the time. X equal. And that number is 3. It's happening at 3. Actually, it's the value excluded in your domain. 3 is excluded. That's your vertical asymptote. Is there a horizontal electric fence? Your curve gets closer to it on the ends. It's 2, right? Then, any questions? It's a very comprehensive, very visual, very instructive exercise. Actually, it teaches you every concept in a low level, right? Because you see it, you name it. How do you do this on paper without any picture? That's our topic next. How do you find vertical asymptotes without these pictures? Again, this is the formal definition of vertical asymptote. It's like an electric fence. Your curve gets closer from the right or left and goes towards it, like attracts towards it, and then just become parallel to it, never touches it. It's vertical asymptote. It's up and down, vertical oriented. But how do I get it from the equation like this one? I don't know the picture of this. I can't make it. I don't have time to make the picture. Even I do, maybe I put the vertical asymptote in the wrong place because it's a sloppy picture. How can I get for sure that vertical asymptote? Okay, it's easy. All you need to do is see what numbers make the denominator 0. So you technically look at only the denominator, forget the top, see what it makes it 0. That's where your vertical asymptote is, but there is a string attached. There is a clause here. It's not that easy. You need to first make sure that all the cancellations and reductions has been done between numerator and denominator to decide that. So you need to first prep your question for the final moment of determination of vertical asymptote. That prep step is you need to factor top and bottom, cancel all matching terms, then whatever is left, you check what makes it 0 in the denominator, and that number is vertical asymptote. So look at this basic question. Can you factor top and bottom and simplify anything here? Can you? Come on, I know you guys are bright enough to cancel these. Right? 4 and 2 cancels, correct?
It's addition, you can't cancel.
Yeah. To be able to cancel stuff on the top and bottom, they must be in multiplication. If this was a multiplication, yeah, you could. But with addition, x and 4 are a block. They're not separable. They're not canceled one by one. They either cancel entirely. If this was x plus 4, yes, you could cancel them. Otherwise, you can't. And stage 1, prep step, is over. This is already ready for decision making. All you need to do is spot what x value makes this denominator 0. -4. You can just look at this and say, but looks can be deceiving. Always set this thing into 0 and compute, okay? Yeah, I did, and it's true, -4. X equal -4 is the vertical asymptote, right? Any objection? It has one of them, and that's called x equal -2. What? It's not -2. -4. Alright. It's getting more challenging. Same type, same question. Different equation, different expression. Oh, I need just to set this denominator into 0, right? That's it. Let's do it. Like before, we said it was x plus 4. I set it into 0. Look, set this into 0. Set that into 0 then. I will go ahead and put that 5a squared minus 21a plus 4 into 0. Okay, who can factor this for me, please? Because I need to factor this so I can break it apart, left side and right side, break it and answer, find out what a is. Otherwise, I can't determine what a makes this 0. Anybody who has good factoring skills?
5a minus 1 and a minus 2. Or no, 20.
Hold on. Set 5. First off, let's break 5 and a squared. 5 breaks as 5 and 1. A squared as a and a. That part I got. So how did you break 4?
I did the AC method. I just multiplied 4 and 5 together and then figured out what added to minus 21.
So 20 and 1. Okay, let's remember AC method. In AC method, we multiply first and last number. 5 is first number. That's 4 last number. That's 20. You get positive 20, sign matters. and then you put 20 here, and you now take the middle number, minus 21, here. You need to find two numbers multiplying into 20, adding to minus 21. What two numbers are they?
-1 and -20.
Yeah, that's how you got it done, minus 20 and minus 1. Because when I multiply them, it's positive. When I add them, it's minus 21. And then you put minus 20 and 1 here. Is that right? No, that part is wrong. Asymptotes uses these numbers to break the middle term into two parts only. So, oops, not too much. So we haven't broken this yet. We just split this middle one into minus 20a and minus 1a. So we have 5a squared minus 20a minus 1a plus 4. AC method is used to break this into two pieces, so we can group these 2 by 2, and this has common minus, this has common 5, right? 5 can be factored, no, not only 5, but also 5a. 5a is common in these two, which is a minus 4. And what is common in this one? -1. That's a minus 4. Good. Right? If I pull -1, it's only a. If I pull factor a negative from 4, it turns into -4. Oh, now with these two matching, we can factor them right down here. And leftover items are 5a. When I remove a minus 4, a minus 4 removing, I have 5a and what is left? Minus 1. Now we have factored it. This is a good review of AC method from 1075, but I know some of you guys can go from here to there by trial error method. You find what two numbers multiply to 5a squared, it's a and 5a. You find what two numbers multiply to 4, but when you FOIL outside terms and inside terms, they match minus 21. There are many options. You can do minus 2, positive 2, positive 2, minus 4, minus 1, positive 4, positive 1. But the only one that makes minus 21 when you add these, this is minus 28, this is minus 1a, is this pair. AC method or trial error, get this. Okay? Alright. What is next? We are ready to set them into 0 if there is a clause, there is a waiting period. If none of these factors cancel with this. Again, this is important, this is key point. Sometimes there is a factor showing up here, same as top, and they need it to be canceled. And only the survivor ones are gonna make vertical asymptotes. Did they cancel anything here though? No, these are not the same. They don't cancel. So both are going to give us one, each of them are going to give us one vertical asymptote. So there are two vertical asymptotes here. How do I get them? I set each into 0 and solve. So this is a equals 4. Just set it into 0 and add 4 to both sides. And this is a equals 1/5. Set this into 0, add 1, divide by 5, okay? Alright, we're not gonna call them A. When they go to here, we're gonna call them x, because vertical asymptotes are in the form x equals something. No, they wanted a. Oh, vertical asymptotes. Oh, f of a, because that's they call it f of a. Yeah, it's not x. So what was that?
4,
1 and 1/5.
4,
4m. 1/5. Yeah, very good. Alright, again, what if this was -4? Again, if I make this -4, what would be your answer? Any changes in your answer? Bottom is the same. So they will factor the same. These two pieces you would get. Now you will still get 2 answers. So your answer won't change. You won't change your answer? Still the same answer? No, if this is a -4, since these two cancel each other, you would get only one VA, vertical asymptote. Okay? It makes a great difference. Alright? So I don't know your homework set. You may have these two matching, so watch out. Mine didn't have any matching. It was okay. Yours may be matching. Okay, the second thing we're going to look at today is horizontal asymptotes. Horizontal magnets that attracts my curve on the far ends. Look, only attraction happening on the right or on the left. Well, can your function go down and cross it here and then go again like that? Yes. For horizontal asymptotes, crossing in the mid part is okay. They may cross. But vertical asymptotes, no. Vertical ones can never be crossed. These never be touched. These are always off limits. Never cross those in vertical. In horizontal, yeah. In the mid part, you may. But how do you find them? Such as question 4. Your equation here, how do you find horizontal asymptotes? Well, it looks like a very sophisticated test for it, but it's quite simple actually. Don't be intimidated by the look. It's easy. It just says first, read and compare 2 numbers called N and M. Letters N and M stands for 2 numbers here. N is the biggest power of the top. So you're gonna tell me, read me N and M. N is the power of the top, M is the power of the bottom side. So what is the biggest power of the top? This is top. Tell me the biggest power.
3x squared.
No, power. Only power. 2. Yeah. You're reading this is the leading term, leader of the group, but the the power is only 2. So the top power is 2. Okay? What is the biggest power on the bottom? 2. It's 2 as well. Look. Okay, I read them. So what? Next, you choose one of these cases. Which case did it happen here? Do you have n greater than m? Or do you have n less than m? Or do you have n equal m here? Obviously, we have, what is the situation here? Equal. So we have, this reads me that n is equal m. So go read what happens if n is equal to m. So we have this situation. If the top power equals to the bottom power, then there is a horizontal asymptote. That horizontal line attracts my curve. But what is its equation? Its equation is the ratio of, you take ratio of the numbers in front of the leading term. What numbers are we talking about? These 2 numbers. 3 and nothing. So is that 0 if there is nothing? No, it's 1 as default. So y equals 3/1 is the H8 here, horizontal asymptote. What are the other cases? If the top is bigger than bottom, no horizontal asymptote. This is the easiest. If you get n bigger than m, such as 3 and 2, you're good. No H8. If n is less than m, the bottom beats the top, top is less than bottom, then we have a HA, which is y equals 0, and you don't have to compute, it's fixed, y equals 0. But if they are equal, this is the most work required part. If they match, you need to compute HA by taking these two numbers in front, or these two numbers in front in this case, which is 3/1 or simply 3. That's it. Any questions? Is the test clear? So this guy has one HA. That HA is 3/1. You don't have to show 1. Now, here comes the other half of the question. We determined HA, but the question continues and asks us whether this graph crosses the horizontal asymptote. I said horizontal asymptotes may be crossed in the middle. How can I test this? I just discovered that. What is our horizontal asymptote? Where is it again? Y equals 3. Where is y equals 3? 1, 2, 3. Here is your electric fence. This is y equals 3. There you go, at 3. And my curve, I know, is going to get closer to this guy. Okay? Maybe underneath it, maybe above. It's going to get close. But my question is, are we going to cross it somewhere and get close? What are these crossing values? If any, maybe it will never cross. It will stay always above. It can be like this. It can be always stay above, and it never crosses, maybe. It never crosses. Maybe it's under, and it never crosses. But does it ever cross? And if so, find those points. All right, I need help. How do I figure this curve crosses the other curve? Y equals 3 and y equals this, cross or not? What do you do? How would you not find out? Oh, you can put it in your calculator and see if they cross, right? Graph them. Now let's say you don't have a calculator. Do you guys cross? This is y equals. How do you test this? Come on, we have to finish this and go home.
Plug 3 for X equals
Okay, you would plug this number in X? That's what you said? No, that's not a good idea. Because this says this is y equals 3. Y is becoming this. You can't put it in X.
Yeah.
If y is becoming this and y is becoming that, if they cross, those y's must match. They must be the same. So these y's must be the same if they cross. So in other words, these equations must be the same then. So we set equations into each other. All right, here comes another question. How do you solve this now? How do you solve this? Because if you can solve and get x's, that's it. Those points will be the crossing points. If you have a quotient fraction like this, what is the first step? Multiply both sides so you can get rid of this denominator. Denominators are evil. We need to first clear them. I'm multiplying both sides with x squared plus 1 so they can cancel. And this side becomes 3x squared plus 3. How about this side? 3x squared plus 3x minus 2. Solving an equation means bringing all x's together and isolating. These are on opposite sides, so I need to bring everything to the left. So I'm going to move these guys left by subtracting their opposites. So we can get here, these are all canceling, become 0, but I need to subtract from this side as well. These are canceling, perfect. And this is not adding up to anything, so it's minus 3x. 3 plus 2 is 5. Now I need to isolate x. I shouldn't have brought this 2 to the left, but I can fix it. 5 needs to go to the other side, right? And minus 3x equals minus 5, and voila. We got it. Positive, when you divide both sides with negative, is 5/3 is where they meet. At 5/3, wherever is 5/3 is, they are meeting. I just discovered that. What is the y coordinate will be? So this point has 5/3 as x coordinate. I'm clueless how to get y, which is, read it. It's 3, because this is a horizontal line. Every point on it has 3. Or, if you really want to push it hard, put 5/3 here, everywhere, and compute it. But guess what? You're going to get this number. Okay? This is it. It crosses, and it's 5/3 and 3. Okay? See you tomorrow.